Hello everyone, welcome to a new video. In this video we will be discussing about how to select a volume control damper for a project. So basically we will be discussing what are the different types of damper based on the mode of operation, based on the type of blades, and then we will be looking into the project specification, how to read a project specification and how to select a volume control damper complying the project specification. Let us start by discussing about the VCD classification based on the types of operation of a VCD. We have two types, parallel blade damper and opposed blade damper. Before moving to the topic, if you lack the basic understanding of the volume control dampers, I have done a video previously speaking about the basics of the volume control dampers. The link is in the description. Okay, so now let us move forward. Let us check what's a parallel blade and a opposed blade damper. The first one you are seeing here is a parallel blade damper. Actually, from the name itself, it is clear what's a parallel blade damper or an opposite blade damper. And once you see the figure, it will become more clear. Still, I will explain what's a parallel blade damper. A parallel blade damper, if you are opening or closing, the blades will be moving in the same direction. For example, you can see a 3-blade damper here. This is the first blade, this is the second blade, and this is the third blade. If I am moving the handle, all the 3 blades will be moving in the same direction. We have the 3 blades, 1, 2, 3. So if I move the blade, you will see that this rod will be pushing these blades all together. So this will go down, this will go down, and this also will go down. And the blades will be like this, for example. See, all the blades will be aligned in the same direction. So this is parallel blade dampers. When we are moving, all the blades will be moving parallel. And coming to opposed blade damper, it will be exactly opposite of what happened in parallel blade dampers. If I move the handle in this direction, like clockwise direction, see, this blade will be going down. Once this goes down, this link will push this blade. So what will happen? This will move in the opposite direction. So the first blade will be coming down and the second blade will be going up. And what about the third? The third will be, when we are pushing in this direction, this will be coming down in this direction. So what will be happening? First blade will be going down, second will be going up. The third blade will be going down and the next will be going up. Similar pattern will happen in the opposite blade dampers. So this is the basic difference. The next classification of VCD is based on the blade types. We have basically 3 types of VCDs according to the blade type. The first one is GI groove blades. The second one is GI aerofoil blades. And the third one is GI aerofoil with the low leakage blades. So let us discuss about these 3 types of VCDs. The first one is GI V-groove blades. It's very clear from the name itself. This damper will be having blades like this. What is showing in the diagram. See, in the ends you will have a V-shaped groove. This will be a single metal sheet with the ends in the shape of V. The advantage of this is when we are closing this damper, this V will lock with the V of the next. Similar pattern will be following. So in fully closed condition, this will be very sturdy and very leak resistant. This is the first VCD type in this class. And the next one is aerofoil shaped blades, like GI aerofoil shaped blades. You can see in the diagram, aerofoil means this kind of shape. We also call this as double skin type blades. You can see it is one skin is here, next skin is here. So double skinned blades or aerofoil blades. This kind of blades promotes a smooth airflow through the blades. Like you can see the shape of this blade. It will provide a smooth movement of air through it. So that is why we call it aerofoil blades. This is the second class. And the third one is aerofoil itself, but with the end of the aerofoil section is with the silicon rubber. we put silicon rubber in the ends so that when the VCD is completely closed, this silicon rubber rubber to rubber connection will be there, and it will be less prone to leakage. These are the three main classes. If you go to the next one, it is aerofoil blades itself, but this metal will be aluminum. Previously we saw GI aerofoil blades. Here the option is the metal is aluminum. So we have aluminum aerofoil blades also, and similarly aluminum aerofoil with the low leakage blades is also there. So basically we discussed about the 5 types. Generally only 3 types are there. The first one was V-shaped blades. The second one was aerofoil blades. Here GI V groove blades, then GI aerofoil blades, and the third one is GI aerofoil with the low leakage blades. That is, silicon rubber will be coated in the end of the blade. I'm telling this for a basic understanding because we will be discussing about the frames and the blades and the project specification afterwards. So just understand that this part of the VCD is called a VCD frame, and this is the VCD blades, like 2 blades are there, and these are in aerofoil construction. We discussed about the blade constructions. This is aerofoil blade construction. 2 blades are there. This is the VCD frame, and this is the VCD handle or the quadrant, and here you can see the lock nut which will lock the handle at a particular position. So let us have a look on a project specification, how a project specification look like for a VCD. So here you can see it is mentioned balancing dampers. Balancing dampers basically means VCD or a volume control damper. So this is a project specification for a particular project of mine. So let us look what the client needs in his project, what kind of VCD he needs. So basically it says install volume control dampers in accessible locations at all branch connections and whatever necessary to adjust the flow of air to secure correct distribution. That is very clear. Casing and blades shall be made of galvanized sheet metal. So what he is asking is frame and blade of the VCD shall be GI and shall be equipped with an approved device for fastening in any desired position. This device shall be that the damper cannot move or rattle, and point shall indicate the position of the damper from the outside of the finished duct insulation. Basically this part is explaining about the quadrant, about the handle and the lock nut. He's telling like once we balance the damper, here people should be able to identify in which position the damper is. That is exactly what is the purpose of the lock nut is. Once we balance the damper with the handle, we'll just lock that position with that lock nut. So basically that is what he's asking. Then dampers shall be aerofoil multi-leaf opposed blade with the blade height not more than 180 mm. Okay, this is clear here. You need a blade of the damper shall not be greater than 180 mm. But here you will identify like aerofoil type blade he needs. We explained, or we already had gone through what is an aerofoil type VCD blade, and also opposed blade type VCD blade. Both of this part we have covered already. So basically he need an aerofoil type opposed blade VCD. All blades shall be operated by a single operating quadrant with the gears and links as necessary. That part also we covered. He is telling like there should be a single quadrant or a single handle with which we should be able to control all the blades in the damper. And the spindle shall be non-corrodable, passing through bearings made of special plastic, temperature resistant to 100 degrees Celsius. Capped bearings shall be provided on non-drive side. These are basic accessories that will come from the manufacturers. The whole damper assembly shall be mounted in a galvanized frame with flanges. The frame shall be galvanized, and it should come with the flanges. We already discussed in the previous video what is a flanged type of VCD. Like basically the frame shall be like a flange. We explained it already in the previous video. If you just have a look on the previous video, it will be able to understand. So basically this is a an example of a project specification, and how we select a VCD for a particular project by looking in the project specification.